What's up, guys? Welcome back to Vanover Customs. Today is another exciting day. We have a new piece of equipment welcomed into the family. Interestingly enough, this piece of equipment is old, like a lot of the other pieces of equipment, and it is a welder. So it is a Miller CP-300. And you know how I like to do it around here? I don't just buy something and start using it. I buy it, I go through it, I upgrade it, I get it to the top of its line in terms of condition that we can, and then we put it right to work. So what we're going to be doing in today's video or series of videos is getting this machine stripped down, remove the old welding leads, the old MIG gun, get it cleaned up just briefly. We're going to replace the MIG gun. We got a new welding clamp, new leads everywhere. We have new drive rollers. We have a fresh roll of wire. New regulator, and then we're going to build a welding cart for it. So I hope you guys stick along for the process and see how this turns out. All right, before we jump into the actual process, let's do some chatting over here. So first things first, I bought this at an auction, sight unseen. It's not tested. I have reason to believe that it does work, but for all we know, it could be complete garbage. Now, I am willing to take that risk because these machines are pretty stout, and if there is an issue, it probably is worth fixing, but that's something we're gonna find out. So the first thing is, why this machine, right? So I wanted a new welder because I have a Miller 211 auto set, and that thing is a great short circuit MIG machine, and I've done way more than probably should be done with that machine. However, trying to do more industrial repair and larger builds with thicker plates, you're going to need something with a little bit more power than short circuit. And so I really wanted something that would do spray transfer, a thicker wire, 045, maybe 16th inch. And so I wanted a machine that would do that. Really, in comparison to a machine like this, I was looking at getting HTP, I think it's a ProPulse 300 or 330, great machine. Obviously I could have got a newer Miller, but I just didn't want to drop 10 grand on something industrial, right? So I could have either gone with a newer inverter-based machine, which is going to be excellent, has all these great features, much smaller obviously, but really what I really wanted was a wire feeding machine. And the reason I wanted a wire feeding machine is because wire feeding machines allow good flexibility and quick wire change because the spool is mounted externally. But really, they're just a more industrial machine, right? A lot of times the wire feed machines, the base unit has a 100% duty cycle, and also you can swap out the guns a little bit easier, you can swap out the lines, and I knew that I wanted to do some bore welding in the future and thought, hey, if I get a machine like this, I can easily switch out the gun to a bore welding gun, and you can do that on a smaller inverter machine too, but I just wanted something heavy duty, and I wanted to be able to know that when I flipped the switch, it was gonna work, no BS, no fancy features, just something that was gonna weld thick plate and do it well. And my good friend Josh Topper over at Topper Machine recommended this machine. He has a couple of these. They're old, 30 plus years old, but they're reliable, and that's the key. A lot of the newer machines, I'm not saying they're unreliable. I have newer machines and they are reliable. But there are certain inverter-based machines that tend to have board issues, and I just didn't want to deal with that. I didn't need anything fancy. I really just wanted something that was gonna weld and weld for many years to come. And apparently these style of machines are really bulletproof. There really isn't much to go wrong, and that's exactly what I wanted. So they do have an older version of this, but it doesn't have the 16-pin plug, and Josh said make sure you get that one so you can run the newer style MIG guns. But aside from that, it's a transformer machine, should be super stout, super reliable, nothing crazy, no frills. It's just gonna work, and that's exactly what I wanted. So specifically this machine, it came how you see it, right? It has a Bernard gun, which actually looks to be in good shape. There are extra consumables, just a variety of things that were laying on the machine. I could have rolled with the Bernard gun, but I really wanted to try out a Tweco. I heard they're way better. So I did get that, and we'll go into that in more detail later. But this is kind of as it sits, how it came. And so we're gonna get this thing stripped down and then see where we're at. Let's start by just getting this cleaned up. All right, I'm just gonna use some purple power and some microfiber rags and get this thing cleaned up. Now, this is not strictly necessary at all, and it's gonna get dirty again, but I just wanna get it cleaned up to start out with so we can see what we're working with and just make it look a little bit nicer, at least in the beginning. I'll bring you back once we get it all cleaned up for the next step. All right, we got the side panel pulled off. I'm just getting the whole machine cleaned, and I didn't expect to do anything on the inside other than just get it blown off and make sure we replace this power cord. And originally, I thought I may have to rewire the machine looking at this terminal plate. The end plug is for 460 or 480 or 440, whatever you want to call it. But when I initially looked at this, I kind of thought that these three wires being in this 230 volt section meant that it was set up for 230, but closer examination, this is fine. Basically these blades here, 1, 2, 3, is what these diagrams are suggesting determines the voltage. So if it was a 200 volt setup, you'd have more blades at all these junction points, and then 230, then you'd have less blades, and then 460, you only have 3, which I have 1, 2, 3. So these terminal plates stay the same, or ring terminals rather, and I think we're set up just fine. So we'll go ahead and get this power cord swapped out just because I bought more of it, and we'll do some new ring terminals and get that all set up, and it should be fine. However, I did find one issue, and it's an issue that would prevent us from getting this thing running. So over here, I wouldn't have noticed this had this not jumped out to me. I was like, oh, this looks like it's a new. And it kind of looks like a motor starter. I'm not an electrical expert, so you guys correct me in the comments. But I seen, oh, it looks nice and new, and I was just kind of looking at it, and I was like, what's this? That doesn't look good. And then I looked a little closer, and I realized that all three of these terminals, and they're marked L1, L2, and L3, they're in these starters just by the skin of their teeth. They're actually using like the edge of the ring terminal to fasten it. So I have no idea if this machine stopped working because of that and they just parked it, or it was working fine and this just laying here was making the connection. But we are definitely going to address that. So I haven't decided, obviously a ring terminal isn't gonna fit in here. They do have a crimp connection back here. I'm not sure how we're gonna address it, but we are gonna address this and replace this cord next. Here's a better close-up. Not only did I realize they did them up here, but as I inspected further and you look close, these are hanging on by a thread on the bottom too. So we'll go ahead and think on that and come back and come up with a better repair for that. Okay guys, off camera I went ahead and made up a handful of these. Basically what it is it's a ring terminal that I cut the end off and then filed it down with a hand file and the belt grinder so that we have a nice little tab. So what I'll do is I will go ahead and remove these and then go ahead and crimp these on and reinstall them. It really is a similar concept here, but hopefully much better execution because the tab is in the middle and it's set up intentionally this way as opposed to just, you know, holding it on the edge where with vibration you could probably wiggle that loose. I went ahead and did one here. It worked out real nice. So we'll go ahead and take each one of these off one at a time as not to mix up the order, and then we'll install one and reinstall it. Using a nice Nipex cable cutter here. I recommend these, they work really well. And because of the size of the wire, we're just gonna kind of use this, rotate it around, like that. All right, then we'll go ahead and get our ferrule or whatever we want to call these installed. I'm just trying to make sure we get all the wires in here, all right? And then I'm using a hydraulic crimping tool. This is just a cheap Chinese one. They actually work really well. And when I do this, I want to make sure I get this set up, and then I'm going to push the wire in while I'm crimping it so it doesn't fall out. I find that for battery terminals, this makes a really nice connection, nice and stout. Now, if you'll notice, it's kind of pinched on both sides. I probably should use something a little bit larger size-wise, but it's what I started on this one, and I'll just stay consistent. And it seems to work really well. Get a nice pinch, and then we'll go ahead and fasten this. All right, it gives a real solid connection. It looks a lot more professional. All right, we went ahead and got these wires set up. That's what they had before, and we have our setup in here. It's nice and tight, nice and rigid, and I went ahead and just installed some heat shrink with the glue on the inside just for extra measure. So that'll be a nice upgrade there. So we'll move on to replacing this power cord and do some new ring terminals and then move on to the next step. All right, we're in here replacing the power cord, and a lot of you guys, myself included, might be asking, why are we changing this? Cords do go bad over time, but overall it didn't look like it was in too rough a shape. And lo and behold, look at this. We have a split right here on one of the line powers. And I think what this is just telling us is that this cord is original, and you can see how brittle this stuff is. So technically, it probably would have been fine. That only did that when I pulled on it. But the reality is this cord is original. So it's probably 30 years old. And so even though it's not technically necessary, addressing this is going to just make me feel better and know that as we use this welder for many years to come, and we're pulling on the power cord, that we're all good to go. We got the old power cord out of there, and we're gonna get the new one in here. This is a 8-gauge SOO cord. All right, we got the ring terminals crimped on there. So we'll go ahead and get these tightened up on here. I'm just gonna put them on loose for now, just to get them in place. And then once it's in place and we have the cord secured, I will come back and get these guys tightened. Take the ground. I left it long intentionally. And look at that, I happen to have some green heat shrink, which is kind of cool. Matches that green ground wire. All right, now that that's done, see how much cord we want to keep in here. There we go. Try to get rid of some of the slack on that. All right, that looks like a good length. So I'll tighten it up in the back, and then we'll come and tighten these nuts up. All right, now that we got the back secured, we can come in here and get these guys tightened up. And just position this so that it's not interfering. All right, that one's good. This black one, just kind of throw it this way like that, yep. I could have made these all different lengths, and I thought about it, but I made them all the same length because sometimes a 3-phase you wire it wrong and you just switch a couple wires. And I could have done that at the plug, but I figured I'd make them all the same length in case I had to switch them around. All right, nice and tight. All right, so I'll come in here with a zip tie down here and just make sure this isn't gonna go anywhere, and then we should be done with that power cord. Throw a plug on the end, and we'll get the machine blowed off and get it started up. All right, we got the power cord sorted out in the back, and we got the inside just blown out with some air. Other than that, everything else should be fine. We're gonna do our first startup. So I'm gonna get the machine plugged in. Now our ground is not attached, neither is our wire feeder. We're not testing to see if it welds or anything yet. I just wanna make sure when I flip the switch, I'm not gonna get an explosion or anything like that. So let's give it a plug in and see how we do. All right, well, the fan kicked on. I didn't turn it on, so I don't know if that's normal. Okay, so the switch might be backwards, or that's normal, one of the two. But either way, I didn't hear an explosion, so I'm gonna call that good. All right, we'll get the shell back on and we'll get it cleaned up, replace these leads in the front, and then continue on. Over at the bench, we have the old cable set up, and we're gonna be replacing these old cables with a brand new cord. So the current cabling over here is 1 gauge, and I'm actually switching out to 2 gauge. Is it necessary? Definitely not. 1 gauge is perfectly fine, but I thought, you know what? We're taking this as far as we can, so I figured I'd go with 2 gauge, so that way we could just have a little bit extra amp flow, and if anything, maybe the cord will run a little bit cooler. Some of the ring terminal ends are looking pretty rough, and we're just gonna be replacing it anyway. Also, you'll notice the ground clamp is over here. Currently, the ground clamp is like 10 feet, and I wanna do a longer ground clamp. I wanna do a 20 feet lead, actually. Yeah, it's probably about 10 feet. And so that's the other benefit of running the thicker cable, is we can do a longer run and maintain that good amp flow. So I'll be doing 20 feet of that, and then also I'll be switching out the traditional ground clamp, which has seen better days, with one of these bad boys. Now some people like these, some people don't. I personally really like these. This is brand new. It's a 600 amp unit. This is a 300 amp machine, so it'll be plenty good enough for what we need. And they are rather expensive, but I really like them because if you're working on a flat plate like this, all you gotta do is set it down and turn it on and you have a connection. You don't have to try to find an edge, and it is more convenient. So we'll be installing this as well as brand new ring terminals, and we'll be crimping those and using heat shrink. So let's go ahead and get these guys installed, and then we'll head over to the welder and get them set up over there. We're gonna go ahead and start with the welding wire that goes from the auto feeder to the positive terminal, and I'm just gonna do this in real time so you see about how long it takes. There's many ways to do this. I actually like using these like lopper type wire cutters, and I just rotate it around. You can also use like a knife. That works pretty well. All right, and then once I get it cut, I'm using a 2 gauge terminal, and it's 3/8 end, but what I'm gonna do is I've drilled these out to 1/2 inch, and on this particular side, we're actually gonna use the original size one, which is 3/8, because this will go into the auto feeder. And then I'm gonna slip this guy on, and this is pretty self-explanatory stuff. All right, and actually, I'm gonna want this a little bit longer. And so while we're doing this, let's just talk about this crimping versus other options. So what I used to do on certain stuff like this is I would solder it. And you certainly can solder it. Soldering works really well. But what I have found, and what a lot of people will tell you, is in a high heat application, soldering is actually not a really good idea at all, because if these cables get to a certain temperature, the solder will melt. And although the solder provides a great connection, it can be very problematic in circumstances like this. I always used to be of the mindset of soldering everything because it's the best connection. And that's mostly true, but in a situation like this, or when you're working under the hood of a car, soldering is not that great of an idea because of the heat. And crimping also gives you a really nice factory look, and it's faster, and so it's what we're using in this case. And this crimper does a really nice job, even though it is Chinese and pretty cheap. It does a real good job. So I'm just gonna, when I do this, it's really easy for the cable to slide out the back as you're fiddling. So I get it in there, and then I make sure I hold the cable while I crimp it. And again, I've picked a crimp that's a little on the tight side, but I'm just gonna use that so that way we have good crimping action. All right. Oh, actually that's turned out perfectly. All right, so there's our crimp. Nice and solid, nice and rigid. All right, and we'll go ahead and do some heat shrink. All right, and for heat shrink, I'm gonna be using the gun for this one. And I've got this really nice, real thick wall heat shrink with the adhesive. I'm just gonna square up my end, cut that off, and then I'm gonna do 4 of these. I also have a lot of these that are pre-cut, which is what you've seen me use over on the other stuff that we did. I have a lot of that from doing car audio, and so that pre-cut stuff is real nice. This stuff is a little bit more expensive than regular heat shrink, but it is worth it because it has that glue on the inside or adhesive, and it really just seals everything. Adds a little bit more durability. All right, so we're gonna slip this guy on, get it where we want it, and then get out our heat gun. And a lot of times you see me use like a torch. Torch works good, it's actually faster, but torch also gets a little too hot. So you gotta have a little bit more skill so that way you can get the heat going without actually burning the heat shrink. I just figured I'd use the gun in this case because it's really hard to screw up heat shrink using a heat gun. The heat is a little more uniform. And this is pretty simple stuff here. Nothing too crazy. Just wanted to give you a real-time shot of how long it takes to do a terminal end here and do it properly to the best ability you can. And I usually like to go until I see our adhesive kind of squeeze out the end, and you know that you've fully allowed the glue to cure. All right, it's hard to see on camera, but got a little bit of glue squeeze out on both ends, and that end is done. So I'm gonna take this over to the welder, and because this is the one going to the feeder, I'm gonna start with this one and then measure it, and then go ahead and cut the other end, and then we'll continue on from there. Well, there we go. It turned out really, really nice. There's the 2 old stuff and the 2 new stuff. It's a very professional connection, very heavy duty, a nice wire, nice and big. The terminals turned out really nice. I'm really happy with this. Hopefully doing it the right way will make it last for many years. So let's go over on the welder and get these installed. All right, the first one here is the connection for the gun. Before, what they had is the wire came out and it ran around the front. I didn't really like that because I didn't want a wire hanging on the outside. So what we did is we made the wire a little bit longer, and I can run it underneath and up the back. I just think it's a little bit cleaner than just running it on the outside of the welder. All right, so right like that. And we'll come back and tighten these nuts here in a minute. But that should be a really clean, nice looking connection. And then we're gonna come up the back instead of around the side. And then we'll come right here in the bottom. And I guess it is possible that it's supposed to come in the top here. We'll find that out once I go to install the spool, but to me the bottom seems to make sense. Look at that, then the washer, and that's why I didn't drill this. I left this 3/8. It was a nice fit on the shaft here. Washer, lock washer, and locking nut. And we'll go ahead and get that guy tightened, and that looks nice and clean this way. All right guys, we ran into another problem. It seems to be, I haven't started the machine, so we don't know if it works, but a lot of the issues that I have found seems to just be from laziness or just hackery in general. Whether it was the issue with the ring terminals, whether it was the switch that's flipped upside down on the front that I did flip around, just in general laziness and just non-caring. and this problem's probably a little bit of the same. So I went to tighten this nut, real simple stuff here, and it's just spinning. And what it is the stud is spinning, and it's, you know, it's obviously my assumption that it's not supposed to spin. It's supposed to be fixed so that you can tighten this down. So I'm trying to get it off, and it's a lock nut, and so it's not spinning off because it's engaged a lock nut, but the shaft is spinning. So I'm gonna try to just zip it, give it some speed, and then we're gonna have to figure out how to fasten that shaft, roll pin or something so it doesn't spin, so we can get a nice tight action. When I came over to the machine, this was undone, and I kind of just assumed, like I've assumed on the rest of the machine, that it was undone so they could take it apart and, you know, start getting it ready for auction, but it may have been undone because whoever went to tighten it couldn't get it tight. So we'll see if we can get that addressed. All right, so this shaft is loose. So basically what I'm thinking is we have a nut on the other side, and a little strange because if you go to break this loose and that nut spins, then you're kind of SOL, but we'll take the cover off and see what's on the other side. But yeah, this is kind of making me think that there's a nut or a bolt, or that this is a bolt. So we'll take a look. All right, it turns out it was a bolt on the other side. A little unusual in my opinion, because I would think, just from an engineering standpoint, that if you're gonna take this cable off, that you'd want that stud to be fixed. Otherwise, you're gonna have to take the whole shell off just to get a wrench on the backside. I guess it's really not the end of the world since we're not gonna be removing this that often. So we'll just go ahead and keep this how it is, and we'll throw a wrench on the back or a socket so we can get it tight. Just a little unusual. I'm sure you guys can kind of correct me in the comments if I'm missing something or if this is normal, but it should be fine as long as we can get this tight. All right, we got that tightened up. Now we're gonna move on to the ground clamp. All right, let's get this ground clamp installed. Real easy. And then off camera, I went ahead and installed this 16-pin connector. Nice and tight. Good connection. All right, very tight, very low profile. I'm very happy with that. All right, next we're gonna get the gun installed. Now, I do have a new gun, but I'm not going to install it yet, and this is why. So with the new gun, it is a direct fit, but I do believe that the wiring harness needs to be adapted, and I am assuming, which is good or bad of me, that this current gun works as it is, or at least it has the correct adapter because it was with the machine. So what I'm trying to do here is just test the machine to make sure it works. And what I would hate to happen is I wire up the new gun and I wire it up wrong for some reason, and I'm thinking that the welder isn't working when in fact we have an issue here. So I want to make sure the gun is working as it is, and then once I know that the machine works and that everything is good from a wiring standpoint, then I can install the new gun, so that way if for any reason I wire it backwards and it's not working, I'll know, hey, it's just the gun and not the machine, and I can switch up the wiring. So that's why we're gonna run with this old gun, just to get it tested, and then we'll switch with the new gun. Well, we had a little bit of an issue with the old gun, so we're over here to the new gun. So the old gun, the problem was, it was set up for 030, and I didn't have any tips for 0045, and that's the wire we have. So even though I wanted to just try the old gun so that way there were no issues, no new variables, we're gonna actually be using the new gun because it will work with the wire we have. And also, we'll see if this connector works. It may work, it may not. When I talked to the guys at Tweco, they said I would have to wire it in, but it looks like it could work, but it also has some extra pins, so we'll see. But anyway, the main point that I want to discuss over here is this Tweco gun. So without getting into too much depth, I have owned solely Bernard guns. Right? I have a Miller 211, and I just bought a brand new, it's a Miller gun, but it's made by Bernard. It's their AccuLock series, and then this machine has a Bernard gun, and it's the older style. And I didn't necessarily have an issue with the Bernard guns. I found that on my other MIG welder, this neck would loosen over time because it was a plastic housing, And even on the new one I just bought, the new neck is getting looser, and it's only been like 2 months. So I'm pretty disappointed with that. However, the rest of the Bernard guns have been fine. But I wanted to try this out. I was recommended these guns by Josh, and apparently the quality is much higher. And I wanted to see if that was the case. And I can tell you without a shadow of a doubt, these guns are far superior to the Bernard guns. Both the older style, the newer style, and the older Miller one that I replaced that was a Bernard style. So now this is a Velocity series, which is their newest style. They have a classic, which is what they're known for, and this is probably a little better than that. But let me just review some of the things that I really, really love about this gun. And I haven't even used it yet, but I can just tell it is a much, much nicer gun. So first, you know, it has this nice cable protecting, and the Bernard gun has that. This seems a little nicer, but that's fine. The cabling is really nice and supple, really flexible. Again, maybe not specific to Tweco, but you can just tell when you hold on to this, this is some quality stuff. The handle has a quick release back here, so you can take this apart. That's really nice for serviceability. I don't think the Bernard has that, but it's not the end of the world. Just a nice little added feature. The trigger has an extension here, which is really nice. So if you want to grip up here, great, and if you want to grip down low, you have, you know, to get away from the heat, you have that extension. I think that's a Tweco thing. I really do like that. But really, the meat and the potatoes, in my opinion, is from here up, right? The neck is metal, and the Bernard has a metal neck, but this seems like stainless possibly. That one's galvanized. Has a nice hook here for you to hook your gun. And then this is my favorite part. Now this is specific to the Velocity series, but this has a 2-piece setup for the tip. So first off, the tips are really nice quality, extra thick, which is probably just because it's a higher amperage gun. But then the actual like contact tip comes out and it's not screwed in. So literally it just sits on there, and when you screw this down, what it does is it sets the gap between here and the tip, and it secures the tip. And the reason why that's really nice is like with the Bernard and Miller style guns, some of them slide on, some of them screw on, but this is very precise, quick, and efficient. And also they've integrated the gas ports into the tip, and it just simplifies it, right? And it's just really nice quality stuff. You can tell that this is a really nice gun, and I think these MSRP for quite a bit of money, $500–600. I didn't pay that. I paid about half that on eBay. But it's just some high quality stuff. And I would recommend, if you're thinking about getting one of these, just get it. It is far superior to the Bernard gun. I haven't used it yet, but you can just tell that the build quality is there. And so I'm really excited. When I started messing with the consumables, I was really excited about that because they offer different tips. They offer a flush, a recessed. They even offer like a pointed nozzle for tight areas, which I got, you know, for getting in tight spots and doing deep roots. And really, I mean, when you look at it, you're like, wow, that makes sense, and it does. Like, why didn't I think of that? But it's just, it's easy, it's quality, it's efficient, and it makes you wonder why other manufacturers don't do quite the same thing. So this is a really nice setup. So we'll go over the machine, we'll get this installed, and we'll move on to the next step. Got this guy, slides right in. Should be a Miller back end. All right, and you want to have your flats up and down, I'm pretty sure, if I remember right. All right, now this is the real test here. Is this connector gonna fit or not? It fits. Question is, does it work? All right, we got a brand new set of drive rollers for 045, and these are knurled. All right, I'm just checking to see, is it 045 on both sides? All right, looks like it. Just loosen this knob so I can get this on. There's one. There's two. All right, new drive rollers, check. All right, let's load this wire up. All right, for the wire, we're gonna be running 045. Let me get it on there, and then I'll tell you the exact style, because I know people wanna know. This is a 44-pound spool, apparently, and I'm not an expert in this. 33 is more common, and this is like an oversized spool. Not sure how true that is. That's what the guy told me. All right, so we are running E71T/12C or 1C. All right, and what this is, just from consulting with a couple other people, this is wire for dual shield. It has a flux inner core, and it's designed to be run with a gas shielding, and it's designed to be run with a higher percentage of argon. So what I have is I already have a massive tank of 98.2, which is 98% argon, 2% CO2. And so if I remember right, the C at the end, maybe it's for the CO2 additive, I'm not sure. But if you're gonna run 75-25, I think it would be a different number at the end if I remember right. So we'll go ahead and get this fed through, and we'll get this powered up and see if we can feed the wire. Yep, I've learned you can't be afraid to admit your mistakes. Even though I've threaded a wire probably a solid 50 times, today when I went to do it, I exploded it maybe 5 or 6 times. All right, we got it fed through. We'll push this down. We're good to go there. All right, we'll fire this machine up and see if our gun's gonna work, and if the machine works, we're not gonna weld, we're just gonna see if it'll feed. All right, here's one moment of truth. We don't know if it's gonna weld, but I do wanna know if it's gonna send signal to the gun. All right, so turn the machine on, fan kicks on. Oh. All right, it's feeding. Oh, that was weird. I like tapped the handle and it started feeding. So I don't know if that's normal. Could be that I have it in jog. Oh, I had the trigger hold on. All right, so let's jog the wire. That's for feeding it. Oh, all right, we probably hit the nozzle. Rookie mistake there. I had the stock 3.5 tip in there. We'll go get our 0.45 tip and go from there. All right, I bought a whole bag of 0.45 tips. This is a good sign. This means I don't gotta rewire the end of the gun. All right, there's our 0.45 tip. Perfect fit. Tighten up. And we're feeding. Slower, fast. That works good, that works real good. All right, I'm happy here. I think we're ready to start welding, at least to try it out. So we got a brand new hose. Go ahead and get this screwed in. And unfortunately my gas tank doesn't have a place because this cart's pretty janky. So I'm gonna get this tightened up, fasten the other end to my tank and set it off to the side, and then we'll meet you back at the bench for the first test welds. And here's a shot of the gas setup because I know people are gonna ask. So 98% argon, 2% oxygen. This is a large tank, I don't know what size it is. It's quite a bit larger than my 125, so maybe it's a 250. And then we got a brand new Miller gauge Smith. So hopefully that's American made. It was quite spendy. Just wanted to continue with the theme of quality here. So there's a bunch of different gas options that you can run with dual shield, and where I get gas, I told them that what I would be doing, and this is what they recommended. So it should work fine. I know there's different ways to do it. So we'll head over to the bench and get this test weld started. All right, guys, the saga continues. So we are having an issue here. I'll explain it before I turn the machine on so it's not as loud. So I went to do a test weld, and before I did that, I just want to make sure we had gas flow, obviously, and I was not getting gas flow. Now, when I hit the jog button on the welder, I am actually getting gas flow. You can hear it at the nozzle. But when I hit the trigger, I am getting wire feed, but not gas flow. So I know I am getting actual flow and there's no restriction, but for some reason there was an electrical issue where the gun is not commanding that flow. I got on the phone with Tweako and I thought, hey, maybe it's back to this plug, because before I was under the assumption I was gonna change it, but he had me jump the pins, And when I jump the pins to complete the circuit, we're still not getting gas flow at the gun. So what that's telling me is we have an internal wiring issue or a fuse or something where we're getting, this is activating power for the motor, but not for the gas flow. So we're gonna dive into that and see what's going on. And I figured I'd just show you so you see it. So the machine's on, and I'll hit the jog, put it up by my mic so you can kind of hear it. And kind of up here, you can kind of hear the gas flow there, but then when I hit the trigger, no gas flow. Gas flow. All right, so we'll take a look at that and see where we're at. Well, we got some fun going on in here. So I do have a wiring diagram for this. It's in the manual, but I didn't print it out. I just kind of glanced at it. And I figured before I got too deep, I might as well call Miller, and if their technical support was good enough, maybe they can kind of walk me through what the issue was. And I was hoping it would be something as simple as one of these terminals were unplugged, but it's not. So basically these three terminals go to the automatic digital readout, which is an option, so that's why they are loose. And the guy kind of walked me through some diagnostics and came to the conclusion that most likely the relay that adjusts the gas control is bad. So apparently the jog button controls the gas flow, but that is a separate circuit than the circuit over here that adjusts the gas flow for the gun when you pull the trigger. And part of the reason why there is a circuit board up here is there's actually a delay with the gas when you pull the trigger. So as he was explaining it to me on the phone, when you pull the trigger and you strike an arc and the arc is made, the gas flow will stay constant. But if for any reason you don't strike an arc and the trigger is pulled, the gas will cut off so you're not wasting gas. Well, that sounds like a really nice feature, but it also sounds a little ridiculous in my opinion, because every time you're pulling the trigger, you pretty much need gas flow, and when you let off, you don't need gas flow, you know, mostly. So the problem is that the relay is surface mount soldered to the board. And I could pull the board and try to solder in a new relay. Could be done. I don't want to go down that road because we still don't know if the welder works. So he was a nice enough gentleman to entertain my idea here, and that idea is to basically do some jumping of some terminals in here, because we know that we can get gas flow when we push this button. So why can't I just set up that so that way when I push that button, we get gas flow? What that will do is that I'll bypass the circuitry that's smart, that is monitoring whether there's an arc being made, but in theory, it should be way more basic. Every time I apply voltage to the trigger, it'll turn the gas on, and when I let it off, it'll let it off. And to me, that sounds like what else would you need, at least in most situations. So I'm gonna do some messing around in here, and I'll bring it back, hopefully once it's fixed. I'll print out the wiring diagram, sit down, and try to achieve that result without getting a new board. I asked him, just because I was curious, and I knew it would probably be laughable, what a new board cost, and $750. So of course that's not worth it. You can buy just the feeder used all day for $500 or so, and it just doesn't make any sense. Also, what I'm thinking is that whoever used this before didn't use it with gas, just based on the fact that there wasn't a gas hose that came with it. And also, if that wasn't working in that manner, they may not have been using it for gas. They may have been using it like straight flux core, meaning there was no gas. So I do need to get the gas working. So what I'll try to do is get that jumped and then bring it back when we have a solution, hopefully. All right, guys, we got some bad news. Now, originally I thought I was just going to jump the trigger over to the jog purge so that way we could get a result, but that's not going to work. And that's not going to work for a couple of reasons. The first of which is that the gun runs on 24 volts DC, and the actual jog switch and everything else, pretty much except for the trim pot, runs on 24 volts AC. I know it's a little bit confusing, but I'm assuming there's a rectifier, probably right there if I had to guess. And basically it takes 24 volts AC from the welder, and then it converts it, because that's a DC motor, and it's kind of what I thought it looked like. And just for efficiency's sake, a DC motor would be better anyway. So that takes and it rectifies, I believe that's, the right word for it. It rectifies or changes from AC to DC so we can power the motor, and obviously the trigger and the adjustment dial is all DC. So we can't just jump a DC switch with the AC signal. That's not gonna work. Also, the second issue that we have is after I was figuring out that and figuring out if there was a way around it, if I could pick up a DC signal somewhere else and jump that, which I couldn't. There's only a couple things here, so it wasn't gonna work. I figured, you know what, let me put that to side. The gun is working, the motor's working. Let me go ahead and just lay down some welds even though we're not gonna have gas flow. And then all of a sudden, it's not welding either. Pretty frustrating, but after I jumped back on the phone with Miller, we figured out that if I can jump pins A and B on the 16-pin connection, I can actually get the welder to kick on and the DC gauge to move for the voltage. Now, I don't still know if the actual bottom unit is gonna weld, but what that's telling me is that when I jump those 2 pins, which is completing the circuit and giving it 24 volts, the welder, like the bottom, not the feeder, turns on. And what that means is it's not getting 24 volts AC from the feeder. And you know what else is not getting 24 volts AC is the gas solenoid. So we're back to the board again. And I hate coming back to the board because like cars, people say, oh, it's the computer. It almost never is the computer. Maybe it's more common with welders for the boards to go bad, I don't know. But the point is that this is a pretty basic circuit inside here. Solenoids, switches, circuit breakers. And for the most part, I've tested everything. But what remains is the board. And the board is doing both the control for the welder and the control for the solenoid. And that control is not working. Now, apparently, and I don't know if this is true, I'm sure it's true, but I don't know how well it's gonna work out for us. The tech guy on the phone, which is real nice, seems to think that it's actually the relay on the board that's faulty, which makes sense. And basically, it's not actuating. How a relay works is it takes a low voltage signal and engages a magnetic coil and then allows a higher voltage to pass through. So because that's not working, it's not allowing our 24 volts to pass through both to the solenoid and back to the welder to tell the welder to turn on the welding. Now, that's a lot of chatting for a basic problem. So we have a couple of options. So option 1 is we can get a new board. Now, I don't really want to do that because a new board is anywhere between $650 and $1,000. But if we do get a new board and that solves the issue, it is worth it as long as the welder works and everything else works. Because if we can't solve this problem of fixing this and or the welder, then we're gonna have to try to get a different machine, and that's gonna get expensive real quick. So if it works, it's worth it, but I'm not sure if I wanna take a gamble yet. The other option we can do is we can remove the board and we can desolder what I think is the relay. It's the only thing on the board that looks like a relay, but I could be wrong. And try to solder in a new relay and source that, because that'll be all of about 10, 20 cents. We're probably gonna try that just because it's low risk and low cost. So we may start with that, and then if that doesn't work and we need to get a new board, then what I may have to weigh is it worth getting a new board or getting a new auto feeder in general? I don't really need an auto feeder with more options, I really don't, but if I'm gonna spend $600 to $1,000 on a dang board and I can get a top of the line auto feeder for $500, $600 more, it may not even be worth messing around with it. And what I would be going for is a 4-roller auto feeder, which just gives you more ability to feed thicker wire and other options as well, just a little bit beefier. But I don't know if I wanna go down that road. So we're gonna start by removing the board. I'm gonna order up a new relay, and then we'll cross our fingers and see where we go from there. Okay, I went ahead and just kind of cleaned up some of these traces here on the end so that you have some of the copper exposed. You normally wouldn't need to do that. You could just solder on these pads, but when I was removing them and going kind of gorilla on it, some of these pads kind of popped up, and so I just want to make sure when I solder this that I'm contacting this pad so that it has good continuity. I've done that in a couple spots where I'm curious about if it's going to work. And then let's go ahead and solder this bad boy up. Easier said than done, huh? Now I am using flux core solder, which I use for automotive stuff. Some have said that using solder without flux would be a little better for this. That may be true, but that's not what I have. Hence, I'm struggling to get adhesion. What I might do I do have some flux here. Let's see if I can add some very liberally. Just to kind of promote some adhesion here. Nice and pretty. See if that helps us out. We got a little ball on there, I'm not sure. Kind of doesn't look like it's melting down to the pad. Well, let's get these balls started and then we'll come back and see if we can try to get it to go down a little deeper. All right, well there it is, guys. We did our soldering on these 6 tabs, 8 tabs actually. The solder bubbled up a little bit more than I wanted to. I wanted to lay flat like these, but I did go back in and just make sure it did sync and that it was going to be a good connection, and that's about as good as I could get it. So I think it'll be fine, but we're going to take it over to the welder and see what we can do and see if this works out. There's the new part right there, and either this will be really exciting and we'll have repaired this, or we'll be ordering a new board. All right, we got the board back installed and everything seems to work out good. We're gonna get this cover buttoned up and get it back over to the bench and see if it welds. All right guys, we're gonna lay down some beads. I've been messing with the settings. I feel like I got it mostly where I want it. Let's see how we turn out. I'm wearing a respirator, so the audio may not be amazing. Guys, I'm pretty happy with that. Looks like I'm running about 500 inches a minute. It's a little hard to tell on this welder. And around maybe 29.5 volts. And we're running 1/4 inch thick plate. I didn't remove any of the hot roll. And dual shield, we're actually running 75-25 because I'm waiting on my CO2 mix. Overall, I feel like this weld turned out pretty decent. Consistency is probably 80%, but we have good adhesion. I'm not cutting into the toes too much, and looks like we have good penetration. Overall, I'm really happy with how this welder is turning out. I'm really excited to put it to work, and hopefully on those bigger jobs where we need to really punch in on some of the thicker material, this bad boy will come in handy. But so far, I'm liking what I'm seeing. We're gonna do another rip of weld. Good. There you go. That has a little bit more consistency than the last one. It looks good. I'm being hard on myself. Probably like 90% consistent. Very happy with our results so far. Man, that was exciting. Seeing this thing put down a decent weld makes me feel real good. Especially when you buy something from an auction and you kind of don't know if it's going to work. I assume that these machines are solid and beefy and could be fixed if it wasn't working, and that was the case. But there for a minute, I was pretty worried. After going through the inside and making some adjustments on the welder, and then going through and fixing the board on the auto feeder, everything is working flawless. Not only is it working great, it looks great. It's on this cart. Everything turned out great. I couldn't be more happy. If you guys enjoyed the process of getting this thing fixed, getting it running, please let me know down in the comments. Hope you enjoyed the video, and we'll see you in the next one.